Polyphytos Bridge is a long infrastructure asset that has a total length of 1,371 meters. It's a landmark transport asset that serves the busy local and national road network. It's connecting the region of Western Macedonia with the capital, Athens in Greece. Nowadays, excessive deflections are being recognized as a well-known, persistent problem in balanced cantilever bridge construction methods across the world. These deflections eventually lead to serious displacements, potential damage, and possible infrastructure failures. In the Horizon project RISKADAPT, we aim to analyze its risks and produce practical tools to promptly adopt measures and avoid infrastructure failures of the Polyphytos Bridge. The key results of the RISKADAPT project are to assist the complicated process of pairing observations with actual damage states, allow earlier detection of damage, and enable more timely and cost-efficient restoration actions. This will help us avoid in the future late damage detection that can lead to extensive socioeconomic consequences and cascading events to climate hazards.
The energy transmission towers are part of a wide power transmission line located in East Finland, which supplies with electricity around 100,000 people. The steel lattice towers of power transmission lines are prone to high corrosion rates of steel and to damage by extreme weather events like windstorms, which are intensified by the actual trend of temperature rise and the climate change. We expect that the interdisciplinary approach of RISKADAPT will lead to gain knowledge of the underlying processes triggered by climate change and to provide relevant stakeholders with a tool for estimating the structural risk of power transmission lines and the socioeconomic impact of possible failure events.
The Catinara Public Hospital serves about 200,000 inhabitants and has two cell towers, one for surgery and one dedicated to medicine. The area is subjected to frequent events of very intense wind that can damage tall buildings, compromising their functionality. These events should be analyzed and estimated. We expect to improve our knowledge and collect relevant information on the impact of extreme events. We will use project data and results also for updating the local building regulation.
Our chosen three structures for study are mainly high-rise office buildings. The window glass shattering during typhoon can be life-threatening and business-damaging. We hope to have a holistic study considering climate change introduces more intense typhoons. Hopefully, we can identify the exact causes, which would be useful for building code requirement. Thank you.